Hello, in this video I'm going to talk about the equation of a straight line, as shown here in the syllabus. The formulas for the equation of a straight line are given on page 5 of your formula booklet. The point at which a line crosses the x-axis is called the x-intercept, and the point at which the line crosses the y-axis is called the y-intercept. In the example shown, the line has an x-intercept of 6, 0. The x-intercept has 0 for its y-coordinate. The y-intercept of the line has coordinates 0, 4. The y-intercept has 0 for its x-coordinate. There are various ways of writing the equation of a straight line. One form is y equals mx plus c, where m is the gradient, or the slope, and c is the y-intercept. This form of writing the equation of a line is often referred to as the gradient-intercept form, or the slope-intercept form. This form is sometimes written as y equals mx plus b, or as y equals ax plus b. For example, in this form, the straight line with a gradient of 2 and a y-intercept of -1 would be written as y equals 2x minus 1. Another form of writing the equation of a straight line is y minus y1 equals m bracket x minus x1, where m is again the gradient and x1, y1 are the coordinates of a point on the line. This form of writing the equation of a line is often referred to as the point gradient form, or the point slope form. For example, in this form, the straight line with a gradient of 2 and passing through the point 3, 5 would be written as y minus 5 equals 2 bracket x minus 3. A third form of writing the equation of a straight line is ax plus by plus d equals 0, where a, b, and d are constants, usually integers, that's positive, negative, or 0 whole numbers. This form of writing the equation of a line is often referred to as the general form, or the standard form. For example, in this form, the straight line with equation y equals 2x minus 1, or equation y minus 5 equals 2 bracket x minus 3, would be written by expanding the brackets and rearranging the terms as 2x minus y minus 1 equals 0. All horizontal lines have an equation of the form y equals c. For example, the line through the given points has a gradient m equal to 0. Therefore, the line is horizontal. And as can be seen in the diagram, the y-intercept of this line is 4. So the equation of the horizontal line shown is y equals 4. All vertical lines have an equation of the form x equals k. For example, the line through the given points has a gradient m which is undefined. Therefore, the line is vertical. As can be seen in the diagram, the x-intercept of the line is 6. So the equation of the vertical line shown is x equals 6. In this question, we're asked to find the equation of the given line, giving our answer in the form y equals mx plus c. If we begin by writing down the formula for the equation of a line and stating that the gradient m is equal to -3. Substituting this value into the formula, and as the line passes through the point with coordinates 4, -5, substituting these in gives an equation in c, the y-intercept. Solving this equation gives c equals 7. So now stating the equation of the line with a gradient m of -3 and a y-intercept c of 7. The equation of the line is y equals -3x plus 7. In this question, again we're asked to find the equation of the given line, but this time given our answer in the form ax plus by plus d equals 0, where a, b and d are integers. If we begin by writing down the gradient formula, which is given on page 5 of your formula booklet, and then identifying the points as shown, substituting the values into the formula and performing the calculation. So on the calculator, I'll press the fraction button and put a bracket around the negative number, subtract 3 and then a down cursor to get to the denominator, and that's 5, subtract 2. Given a gradient m of -4/3, we can then use the formula for a straight line, y equals mx plus c, substituting in our value of m and substituting in one of the points that the line passes through. I've chosen to use the point 2, 3 to give an equation in c, the y-intercept. Solving the equation gives c equals 17/3. Now stating the equation of the line in the form y equals mx plus c. To give the equation in the required form, we can multiply both sides of the equation by 3 and rearrange the equation, collecting all the terms on one side, giving 4x plus 3y minus 17 equals 0. Alternatively, having found the gradient of -4/3, we could use the formula y minus y1 equals m bracket x minus x1, replacing m with -4/3 and substituting in the coordinates of the point 2, 3. To give the equation in the required form, we can expand the brackets, multiply both sides of the equation by 3, and again rearrange the equation, collecting all the terms on one side, giving the same answer as before. In this question, we're asked to find the coordinates of points A and B and the area of triangle AOB, where point O is the origin. As the line intersects the y-axis at point A is the y-intercept, which has an x-coordinate equal to 0. Writing the equation of the line and replacing x with 0 makes the first term equal to 0. And solving the equation gives y equal to 2. So the y-intercept, A, is the point 0, 2. Since the line intersects the x-axis at point B is the x-intercept, which has a y-coordinate equal to 0. Writing the equation of the line and replacing y with 0 makes the second term equal to 0. Solving the equation gives x equals 3. So the x-intercept B is the point 3, 0. At this stage, it might be helpful to draw a diagram, plotting points A and B, and identifying point O, the origin. And to find the area of triangle AOB, if we state the formula for the area of a triangle, replace the base OB with 3 units and the height OA with 2 units, and then calculate the area. So the area of triangle AOB is equal to 3 units squared. In part A of this question, we're asked to find the equation of the line given in the form y equals mx plus c. So we have to rearrange the equation. Subtracting 3x from both sides, then subtracting 6 from both sides, and then dividing both sides of the equation by 4, and simplifying the fractions to give the answer shown. As the equation is now in the form y equals mx plus c, we can state that the gradient m is equal to -3/4 or -0.75. And the y-intercept of the line, c, is equal to -3/2 or -1.5. In this question, we're asked to determine whether a tanker located at point A is on the trajectory or the path of the sailing boat. If we begin by writing down the equation of the path of the sailing boat and the coordinates of point A, the location of the tanker. Substituting point A into the equation by replacing x with 3 and y with 12. And performing the calculation, 2.5 multiplied by 3, subtract 12 plus 3, gives a value of -1.5 on the left-hand side. However, the right-hand side of the equation is equal to 0. If the left-hand side was equal to the right-hand side, then point A would lie on the line. But as -1.5 is not equal to 0, in other words, the value on the left-hand side is not equal to the value on the right-hand side, we conclude that point A does not lie on the line, i.e. the tanker is not on the trajectory of the sailing boat.